Okay, guys, I'm in a hurry. I want to leave today. This is my solar car, and I've been here for nearly a month. Visited a guy with lots of greenhouses, and he had a problem with watering all the plants, and so yeah, we built a solar pavilion. I don't know if it's also English. And so I just want to talk a bit about this, how to cheaply build the electric and all this thing. Interesting thing is here we have these very cheap, these are not the standard crystalline cells, and you can get them for down to 10 cents per watt, whereas these better ones you still have to pay about, used ones about 20 cents. And you can get these for 10 cents a watt, down to even 5 or 6 cents a watt, because these have a low efficiency. But 10 years ago, farmers really made big power plants with these ones, and they got a lot of money for them for 20 years. And it's a good idea to them to repower them, because then they can put twice as much solar power on their land and still get the high interest based on these cells. Therefore, these very cheap panels are now on the market here, at least in Germany. And the special thing about these ones is they have 120 or 110 volts. And so we took these two and simply connected them in series, and yeah, this is 220 volt DC. But nearly everything that is a power supply with not a coil also runs with DC, as well as all these drilling machines with carbon contacts. And so this is really the cheapest thing. You see, such that's a 100 watt panel too. Is it's 10 euro, 20 euro, and this thing, and then you can already, because that was a basic idea for watering plants. You only need to water plants when the sun is shining, because then it's going to be dry, and therefore when the sun is shining, well, then you have the electricity. So you do not really need expensive batteries, expensive power inverters. You could really use directly solar panels without any batteries, and power a water pump or a ventilator. And therefore that was the first experiment. But then we decided, well, okay, we want big pumps, 2000 watts, and the big pumps have condensator capacitor motors, and a capacitor motor does not run with direct current, and therefore, well, here that's a 2000 watt up to 4000 watt inverter, 24 volts, and behind you see two of these cheap 12 volt batteries, and that's these batteries up here, panels up here. You have to look at the solar panels, but the standard solar panel has about 30 volts MPP power voltage. And okay, you have to take care that when they get hot, the MPP voltage it goes down to 25 or 26 volt, and then you get problem charging the battery. And therefore it's 4 times 260 watts, so 1 kilowatt, and we got 1 kilowatt when it was cloudy, and then the sun came out, and so the panels were not hot already. And so but it's, you see, if you do not need an MPP charger, it's just here a simple $30 60 amps charger. And when you have the battery, that's my experience, when the battery is already quite nicely fits to the MPP voltage of the panels, then you are better off instead of taking a 60 volt panel or a 30-volt panel and an MPP charger, and charging only a 12-volt battery. Because on cloudy conditions, I haven't seen yet any MPP charger that really runs good under cloudy conditions. And here in Germany we have 1000 sun hours and about 2000 or 3000 cloudy. I needed to free some space. So that was about the solar panels, and here that's the construction. So it's a nice place here to sit, and here it's to work. And so electricity, everything's up here. I have windows inside, so it's intended to be open, so with the wind and the storm, that the thing is not flying away. And here's a bit about the electricity. So these are very cheap and nice things, only $2 from eBay. And so these so some switches, and here that's for the to move up and down, and here's the electricity. So if we want to move up, let's say here, and first that's on, and now we can put on the this is then here, windows going up. Yeah, the water. It's a very simple turn off again, move down again, and turn on again. So here the water pump, and here inside another box, and there is this 4-channel relay, and this time it's just 5 volt, and these 2 of these 4-channel relay modules. And so yeah, here tomatoes and everything biological. And here's the second, so there's another 4-channel relay, and so it's a a cable with 8 pins. That's FTP, a LAN cable. And so it's right now it's simple, a switch on and off to control these motors. And the problem is you have to take care that you only turn on. Even better, look here, that's very nice. It's to make seeds, and here we have aubergines, or I don't know. So this is lots of wonderful vegetables. And so the problem is it's these 10 Ampere they freeze when or melt together when you turn on turn on off the switches while the motors are under power, and therefore you first have to pre-select here everything. So this is a 5 volt, so now the 5 volt is off, now the 5 volt is on, and here you can decide whether these 4 motors go up or down. And this is to turn the 24 volts for these motors, because you can turn off the power for these motors, and then you can still here switch on off 3 power sockets for the water pumps. And when you have pre-select everything, then you can turn on off. And I think I have switched off here while the power was on, and this is always a risk that a relay freezes. So I hope after the video it's still working. Yeah, that's about 2 or 3 weeks of work, and I'm happy that a friend here he paid for it. But it's very helpful, I think, for him, because now he has water, how much you like. And I still think these tunnel greenhouses, they were cheap, but they get very hot inside. So here again, tomatoes. But I think it's now as we have electricity, is however much we want. There could be some big ventilators here, And so I have to still calculate. I did already calculate the heat capacity of air going from 30 degrees Celsius to 50 degrees Celsius, and then I think with 100 watt, now 300 watt of ventilators, we could pump out 8 kilowatt of heat, but this is about 150 square meters, and so it's about 150 kilowatt of heat when the sun is shining. But these plants, they vaporize moisture and cool themselves, and so I still have to calculate the vaporizing of water and the humidity of 100%, the humidity of 50%. So let's say going in 50-degree humidity and going out 100% humidity, then you can calculate how much cubic meter of wet air you would have to suck out to get these. And I'm confident that, you see, because to boil water, that needs a lot of energy to get the water into the air. And so I think the heat capacity of air, as I said, 8 kilowatt, that's a minor thing. The biggest thing to get the heat out is the moisture. And so that's something really. We have 1 kilowatt of solar power. If it's cloudy, we still have 100 kilowatt of hour. And so I think these tunnel greenhouses could be still a good, better solution than these one, because here you open the window and then all the moisture goes out, and you do not want to do that in Africa. But if you would pump out the wet air and then would go underneath the soil, so the moisture condensates out and would go down to the 3 meters below we have the water, and then we could pump it out again, and then it would really be self-sustainable, no moisture going out. And so this is something I would like to test, or maybe you will give me feedback. You see, to use solar power in combination with such a tunnel greenhouse and the ventilation, to really cool the winter. So yeah, okay, bye. As I said, I'm in a hurry. So here, that's paprika, aubergine, some tomatoes for me, and so yeah. Hope you like it. Bye.